All right. Let's look at a specific problem that I want to look at. The first example that I want to give you is this problem right here. So if you've got, notice this, I'm going to walk through this. The original problem, if you look at it, and first of all, check and see if it qualifies for L'Hopital's rule. You plug in 0 to the numerator, and you get the sign of 0, which is 0, minus 0, which is 0, over 0. So you get 0 over 0. That's evidence that that qualifies for using L'Hopital's rule. So that's what it's saying here. The sign of x minus x is 0, and the limit of x squared is 0. Therefore, it's an indeterminate form of the type 0 over 0. So what we do is we can take the derivative of the numerator and the derivative of the denominator, find the same limit, the limit to the same value of the derivative, and that answer will be the same answer as it was for the first part, okay? And in this case, it turns out you've got to repeat the process. So let's look what happens here. We get 0 over 0, so we're going to use L'Hopital's rule. Take the derivative of the top. Take the derivative of sine x over x, minus x, and the derivative of sine is cos, and the derivative of minus x is minus 1. Okay, then we've got the situation of we've got to check the denominator. The derivative of the denominator is 2x. Okay, so now the idea is check and see, does it qualify? Does it give us a solution? We check the numbers now again now. Plug in 0 for the limit. All right, so we've got this value up top. Plug in 0 to cos. Cosine of 0 is 1. 1 minus 0, 1 minus 1 is 0. Okay, and when you plug in x to the denominator, you get 0. You get 0 again. So you've got 0 over 0 again. In the problem, they pull this 2 out and make it 1/2. You don't have to do that. You could do it. But the end result would still be 0 over 0. And notice what it's saying. The wording here is saying that the 0 over 0 happens again. It's of the type 0 over 0. So use L'Hopital's rule again. Boy, this is getting challenging a little bit. All right, so here we go. So the idea now is, now we got to take the derivative again. And this is what they're showing here. Okay, so take the derivative of cos, and you get negative sine. Derivative of minus 1 is 0. So I got negative sine on top, and the derivative of x on the bottom is 1. So now we plug in 0 into this function, and the answer to this will be the answer to the previous two rational functions also, and including the original. So it ends up being the limit as x goes to 0, the sine of 0 is 0. 0 over 1 is 0. So remember, 0 over 0 is not equal to 0. When you have the type 0 over 0, that's saying you don't know the answer. There's something more you got to do. So they call it indeterminate. But it turns out after you take the derivative the first time and then take the derivative the second time, when we take the limit as x goes to 0, you get the answer to 0. Therefore, the answer to that problem is 0. Okay? So this is the first example. I'll do another one, and they'll both be on As You Learn. Try them, and we'll go from there. Okay? If you've got questions, make sure you get in touch with me.